Our first example is a 2 by n game, and this particular is 2 by 3. Here in this table, we'll calculate payoff values for player A with the help of this game, and here we'll do some graphical work. Before we start our graphical work, we'll learn something more about this term probability in the studies of game theory. This is an example of mixed strategy. These values are called probabilities. So the sum total of all the probabilities of player A is 0 plus 2 by 3 plus 1 by 3 equal to 1. Similarly, the sum total of all the probabilities of player B is also equal to 1. Let's see another example. Sum total of all the probabilities of player A is 2 by 5 plus 3 by 5 equal to 1, and sum total of all the probabilities of player B is half plus half, which is also equal to 1. So sum of all the probabilities for any player is always equal to 1. So here total number of rows are only 2. One is R1 and the other is R2. And we assume that the first row R1 has probability of X. We don't know the exact value, so we just put a variable here. So the probability we must assign to the second row R2 is 1 minus X. Because their sum total should be equal to 1. And by adding X and 1 minus X, we get the value of 1. So first we have to assign probabilities for R1 and R2. If R1 having probability of X, then R2 1 minus X probability. Player B C1, C2 and C3, 3 strategies. Now if player B is playing in first column, then payoff for player A is minus 3 times X plus 2 times 1 minus X. Minus 5X plus 2. If B is playing in the second column, then payoff for player A 4 times X plus minus 2, 1 minus X. Six X minus 2. And for the third column, payoff for player A is 2X plus minus 1, 1 minus X. Three X minus 1. Now, if we put X equal to 0 in this equation, so this is plus 2. X equal to 0 in this equation, 0 minus 2 minus 2. X equal to 0 here, and we get minus 1. Similarly, X equal to 0, 1 in this equation, minus 3. X equal to 1 in this equation, 6 minus 2, 4. And X equal to 1 here, we get plus 2. And now we have to plot all these values in this graph. But before that, we'll learn some basics of this graphical structure. This complete vertical line, vertical axis, is representing x is equal to 0. X is equal to 0 does not mean by this point, this origin. This is confusing for some students. And you must be very clear, x equal to 0 is an equation for this complete vertical axis, not any particular point. So all these three values we obtain by putting x equal to 0 in the equations. We are going to mark them on the same axis, x equal to 0 axis. And the second vertical axis is represented by x equal to 1. All these three values we obtain by putting x equal to 1. We are going to mark them on this x equal to 1 axis. So x equal to 0 is an equation for left side vertical axis, and x equal to 1 is an equation for right side vertical axis. So these three values we should mark on x equal to 0 axis, and remaining three values on this x equal to 1 axis. First pair is 2 and minus 3. This is plus 2. This is minus 3. And we need to draw a line joining these 2 points. And this straight line is representing C1. Second pair, minus 2 and 4. This is minus 2. This is plus 4. C2. Last pair, minus 1 and 2. This is minus 1. This is 2. Strategy C3. Now we have three straight lines representing all the three strategies of player B. It may be 4 or 5 straight lines if our given question is a 2 by 4 or 2 by 5 matrix. And with the help of this graphical structure, we can reduce all the extra number of columns except only 2 columns. Except only 2 columns, we have to cancel all the other columns. And this is the main objective of all this graphical work we are doing right now. And these are the steps. If we are working on a 2 by n game, we must select the lower area of the graph which is covered by 2 or more straight lines. This is the structure we have till now, and we have to highlight the lower area according to our rule. But one very important thing I should mention here. While defining the lower area of the graph, we must not consider this central horizontal axis. I repeat, we must not consider this central horizontal axis. Simply ignore the central axis. And then this is the lower region, which is covered by all the three straight lines. Sometimes it could be only few of them, and sometimes all of them. Now, we need to pick the highest point, and that point is called Maximin. You know the meaning of Maximin. It is the maximum value among all minimum values. In the similar pattern, we just picked out the highest point of the lower region, and that is why the point is called Maximin. Few other short examples to help you understand better. Suppose we have 4 straight lines like this. For any unknown 2 by 4 game it is. First, we ignore this central horizontal axis, and this is very important step. Then we select this lower area. And this region is covered by 3 straight lines. This could have been only 2 lines or even all the 4 lines. And this point is Maximin, the highest point. Next one, 3 straight lines we have now, and the lower region is covered by only 2 of them this time. The highest point is Maximin. So that's how we pick the Maximin for any 2 by n type game matrix. And the rule is similar for a m by 2 game matrix. But there we'll have to select the upper region which is supported by two or more straight lines. So just highlight this lower area like this. And then the peak point is our Maximin. And this Maximin lies at the intersection of C1, C3 it is, and C1. C3 and C1. Now I'll prepare a 2 by 2 matrix. This is R1, this is R2, and the columns are C1 and C3. C2 is cancelled. And that was the objective of this complete graphical work, to reduce all the extra number of columns except only 2 columns. So either we are using graphical method or the theory of subgames in previous chapter. Each time our main objective is to get a 2 by 2 game matrix so that we can apply arithmetic procedure. So we are calculating oddments right now. Difference between these two numbers, 5. Difference between these two, 3. Between -3 and 2, 5. And between these two, 3. So we can calculate our game value with the help of these oddments. Game value 2 multiply 3 plus -1 times 5 divided by sum of these two. One by 8. And this is also the value of our Maximin. In the actual graph paper, you will see this point at the distance of 1 by 8 from the central horizontal axis. Optimal strategies. First, we need to calculate probabilities. The same oddment 3 divided by 3 plus 5. Here 5 divided by 3 plus 5. 3 divided by 3 plus 5 again, and 5 divided by 3 plus 5. So first for player A, first row R1 probability is 3 by 8, and second row R2 probability 5 by 8. For second player, player B, first column 3 by 8, second column C2 is cancelled, so 0 probability, and for the last column 5 by 8. So 1 by 8 is game value, also the value of Maximin, and this is optimal strategy. Our second question is the other type, m by 2 type. Now we have a 3 by 2 game matrix, and this time number of columns are only 2. So we should assign probabilities for columns this time. If for the first column probability is y, then for the other column it's 1 minus y. We are using variable y for a m by 2 type game matrix. For a 2 by n type game matrix, in the first problem, we have used variable x. And the other changes are, we'll calculate payoff values for player B this time, for every respective strategy of player A. Player A has 3 strategies in the form of 3 rows, and according to each of them, here we'll get payoff values for player B in the form of 3 different equations. And in the graphical structure, these 2 vertical axes are named y is equal to 0 and y is equal to 1 this time. So the first column, y probability, and the second, 1 minus y. Player A is having R1, R2 and R3, 3 strategies in the form of 3 rows. Now if A is playing in the first row, payoff for player B is 5 times y plus 3 times 1 minus y. Equals 2y plus 3. A is playing second row, then payoff for player B 2 into y plus 4 and 1 minus y. Minus 2y plus 4. For the third row for player A, payoff 1y plus 6 1 minus y. Minus 5y plus 6. Now if you put y equal to 0 in this equation, we get 0 plus 3, 3. Y equals to 0 here, 4. Y equals to 0 here, 6. Y equal to 1 here, 2 plus 3, 5. 1 here, minus 2 plus 4 plus 2, and y equal to 1 here, plus 1. First pair is 3 and 5. This is 3. This is 5. And the straight line is representing strategy R1. Second pair, 4 and 2. This is plus 4, this is plus 2. Strategy R2. For the last pair, 6 and 1. This is 6, this is 1. Strategy R3. This is the upper region, supported by only 2 straight lines. And the lowest point, this one, of the area is our Minimax. and our minimax lies at the intersection of R1 and R3. So to prepare this 2 by 2 matrix, we have only R1 and R3. We just cancel second row with the help of graphical work. And now we can obtain the game value and optimal strategy for both players by standard rules. Difference between these two, 2, and these two, 5. Difference 4, and here 3. So our game value 3 into 5 plus 6 into 2 by 5 plus 2. 15 plus 12, 27 by 7, and this is 3.85, also the value of minimax. Value of minimax is 3.85, and that means on the actual graph paper you will find this point minimax at the distance of 3.85 from the central horizontal axis. Now the optimal strategies. First, probability. The same odd man 5 by 5 plus 2, and 2 by 5 plus 2. Here 3 by 3 plus 4, and 4 by 3 plus 4. For player A, first row R1, probability 5 by 7. Second row R2 is cancelled, 0 probability. And for the third row, 2 by 7. For player B, first column 3 by 7, and second column 4 by 7. Our game value is 3.85, also the value of minimax, and this is optimal strategy.